Welcome once again to the night class. Today we are going to review our chapter 6 from Advanced Math Plus, and that is basically doing some more trigonometry. This chapter was mainly dealt with radians, so we got introduced to what radians were and how to use them, and let's get going. So the first three we are simply converting. They give us the angles in degrees, and they want us to write the angles in radians. So it's very, very simple. These problems should be easy. You do need to show your work, but the work is not much. There's not much to show. So all you're going to do when they're going from degree to radian is you're going to multiply by pi over 180 degrees. Okay, leave your pi. It says write it in terms of pi. That's not an n, that's a pi. Okay, right there. So leave it in terms of pi, and basically you just put negative 435 divided by 180 in your calculator and hit math, enter. Let me see if I can do that. Just do negative 435 divided by 180 in your calculator, hit math, enter. And it's negative 29 over 12. So you write on your answer sheet negative 29 pi over 12. You just put the pi in with it. Okay, same thing on number 2. We're going to multiply by pi over 180. Again, 585 divided by 180, math, enter, is 13 pi over 4. And last but not least, 36. If you multiply it by pi over 180, and again, you just do 36 divided by 180, math, enter, you will get 1/5 pi, which is basically just pi over 5. That is the only work you need to show. Show me that you know to multiply by pi over 180, and from there it's putting it in your calculator. Very, very simple. I mean, you can reduce the fraction in your head, but the calculator, if you have it, is always an option. Okay, 4, 5, and 6, we're doing the reverse of 1, 2, and 3. Instead of going from degree to radians, we are going from radians to degrees. All right, so we do exactly the same thing except the opposite. So rather than multiplying by pi over 180, we are going to multiply by 180 degrees over pi. Okay, the pi's will cancel, and you just say 13 times 180 divided by 15. You should get 156, and that is degrees. Okay, it says for these, round your answer to the nearest tenth if necessary. So it wasn't necessary on that particular problem, but if it is necessary, we're going to round it. Okay, 11 pi over 3. Again, show your work. 180 degrees divided by pi. The pi's will cancel. You multiply 11 times 180 divided by 3. You get 660 degrees. And last one for this section, 180 degrees divided by pi. We're going to multiply. And again, we're doing that because 180 degrees and pi radians are equivalent. They are equal. So we're basically multiplying these by 1 on all 6 of these. Okay, so that will cancel. When you put that in your calculator, you will get negative 810 degrees. Very, very simple, nice, quick, and easy. This should be fairly easy test. Quick to do. 7 and 8, it says, given the measurements of the central angle, you are finding the length of the intercepted arc. So this is going to require you to memorize a formula. The formula is S, which stands for arc length, is equal to R theta. Okay, that is the formula you need to remember. Don't forget your theta must be in radians. So if it's not in radians, you need to put it in radians. Okay, so to do this one, it tells me my radius is 10. It gives me my central angle. Okay, that's your theta. and it's basically just plugging in. So S will be 10 centimeters times 3 pi over 4. That is already in radians, so I don't have to worry about that. Put that in your calculator and you get 23.56194449, but that rounds to the nearest, wants to round to the nearest tenth, so that will be 23.6 centimeters. Boom. All there is to it. Okay. Number 8, 75 degrees. We're going to use the same formula. S equals R is still 10 centimeters. However, they give us our angle in degrees, so we don't put 75 in there. You have to put 75 pi over 180. That changes it to radians, okay? And then stick it in your calculator. That will give you 13.08996,939, which rounds to 13.1 centimeters. And that's all you do there, okay? 9, 10, 11, and 12. These are probably require the most thinking, okay? They're not hard, but they do require a little bit of thinking. So our first step to do these is we are going to figure out, and I'm going to, I'll write the answer, but I'm going to give me some room because I don't really have enough room to work these. So I'm going to erase everything but number 9 right now, so I have plenty of room to work. And we will go back, and I should have done that in a different way. Let me try that again. So I'm going to erase 10, and then erase 11, and then erase 12. And that way I'll add them back as we go, okay? So this will equal sine, I've already messed up. Let me see here. I need to get rid of that radians. I need it to be degrees so I can, because I'm more familiar with degrees. So I'll multiply by 180 over pi. Okay, that will be sine of 300. So 300 degrees is in quadrant 4, and it has a 60-degree reference angle. Okay, so basically we're doing the sine of 60 degrees. I'm going to do my hand trick, okay? See if I can do it here. Where's the camera? Boom. Here's my hand, okay? So, man, the hand looks big in here. All right, so 60 degrees, that's 0 degrees, 30 degrees, 45 degrees, 60 degrees. We are doing sine, so sine is the number of fingers to the right, which there are 3. So the square root of 3 over 2. Boom. All there is to it, okay? So this is going to be the answer, square root of 3 over 2. Now, what quadrant is it in? Remember, we have all star trig class. So sine right here is positive in the first 2 quadrants. It's negative in the 3rd and 4th quadrant. So my answer needs to be negative, okay? I'm going to leave that up there just for a second. And we'll keep going doing the other problem. Let me write that answer a little better. There we go. Negative square root of 3 over 2. All right. Let me erase this. And let's do number 10. Okay. Get rid of 11 there. And we're basically doing the same process. Okay. Tangent this time. Tangent, we'll multiply it by 180 over pi. That will be the tangent of 840, I believe, yes. 840 is a little too big, so if I subtract 360 twice, I will get that down to tangent of 120, and now I can work with that. Okay, so I draw my coordinate plane here. 120 is in the first quadrant, okay, and it's also got a 60-degree reference angle. So again, let me go back to the camera. So 60 degrees again, we have 0, 30, 45, 60. This time it's tangent. So remember, tangent is the square root of the number of fingers on the right divided by the square root of the number of fingers on the left. So that's square root of 3 over 1. So that will be square root of 3 over the square root of 1, which is just square root of 3. All, star, trig, class. Second quadrant. The second quadrant tangent is negative, so that will be negative square root of 3. Okay? Do another one. And 11, cosine of pi over 2. That one's actually pretty easy. Pi over 2 is 90 degrees. So this is where 90 degrees. It's not in a quadrant. It's up here. Its point, if you use the unit circle, is 0, 1. And you need to remember for cosine, in the unit circle, cosine is equal to x. So what is your x? It is 0 is your answer there. Okay? So if you've forgotten, I'm using rock, excellent rock, excellent on that one. So cosine is x over r, so 0 over 1. Boom. Alright, and then last but not least, number 12, multiply by 180 over pi. That will be sine, let's see here, what do we get? 630. And that's a little too big again. If we subtract 360 just one time, we will get sine of 270, which again is not in a quadrant. 270 is down here. That point on the unit circle is 0, negative 1. I just wrote them down. Rock is sine, so it's y over r, so y is negative 1. So negative 1 is my answer because r is 1, so it'd be negative 1 over 1. Okay? Those are pretty much take the longest amount of time to do. 13 and 14, we're finding the area of each sector. Make sure you're using the appropriate formula for each problem. So this one you also need to know the area formula. It's 1/2 r squared times theta. And again, theta needs to be in radians. Okay? Got to be in radians. If it's not in radians, you make it in radians. So this is all this is plugging in. 1/2 r is 6 feet squared. 6 pi is in radians. You just stick that in your calculator. You will get 339.292 blah blah blah. Rounded to the tenth would be 0.3 square feet. And then area for 14 would be 1/2. My radius is 48.5 meters squared. And my angle is 135 degrees. It's in degrees, so I have to make it radians. 135 pi over 180. And then you just stick it in your calculator. So that's, let's see here. Put that in your calculator. You should get 2,771.179245. So it would be 0.2 meters squared. All right. So last, what's that, 5 problems? These are just, you have to find the amplitude, the period, the phase shift, and the direction. You do not have to graph them, and the vertical shift, sorry. You do not have to graph them, you're just finding those things, okay? So if you'll remember, amplitude's really easy. It's whatever that number is in the front. It's always positive, so amplitude is 3. Your period is 2 pi over k. So 2 pi over k in this problem is 4. So your period is pi over 2. Your phase shift is negative c over k. So that would be negative c for this problem is negative pi over 4. divided by k was 4. That will be positive pi over 16. And since it's positive, it is to the right. And then finally, your vertical shift, it's nothing there. So it is 0 or none. Okay. 16, we don't really have a lot of room, so I want to make some room for 16. I'll erase this one for a little bit. So 16, amplitude is 2. My phase shift, or my period, excuse me, we'll do period first. 2 pi over k, which is k in this problem is 2. 2 pi over 2 is pi. My phase shift, as you can see, there is no parentheses, so there's no c, so it's just 0. And my vertical shift is -5, which would be down. Okay. Last but not least, gonna erase that answer. So hopefully you got it. Just rewind the video if you didn't. Pause it. For this one, amplitude is, there's a understood 1 there. So amplitude is 1. Period is 2 pi over k. K in this problem is 1/2. So that will be 4 pi. Phase shift is -c over k, so that'll be negative, there's c, negative and negative 2 pi over 1/2. That is a positive, would be 4 pi. And since it's positive, it goes to the right. And my vertical shift is just 3. And it's positive, so it goes up. All right. So for the last two, we're going the other direction. They give us the answers, so you should at least know half the answer just by looking at it. So it's y equals, and I'm going to write where can I write it? I'll write it over here. It's always y equals a sine of k theta plus c plus h. And basically, they give you a and h, and you have to find c and k. Okay, so amplitude, and I put sine, but this one is saying cosine, so we do cosine. So a is 2.9, but we don't know if it's positive or negative, so we're going to put plus or minus 2.9 cosine of something, and then I know my vertical shift is -3, so I know on the end it's going to be -3. I got to figure out what goes in the parentheses. So let's find k first. So my period in this problem is 2 pi over 5, and it is equal to pi over k. So work that out. That will be 2 pi k equals 5 pi, and all I did there was cross multiply and then divide by 2 pi. Those cancel, so those cancel. K is 5 over 2, so it's 5 over 2 theta. And then to get the c is the phase shift, so negative c over k is equal to the phase shift, and the phase shift was negative pi over k. So that will be, let's see here, c is what we're looking for, so negative c, k was 5 over 2, so negative c over 5 over 2 equals negative pi over 2. Okay, and basically we're just going to multiply. I'm actually going to multiply both sides by negative 5 over 2 to cancel out that negative. Okay, and when I do that, those cancel. Okay, those cancel, and c is positive 5 pi over 4. So I'm just going to put plus 5 pi over 4. So that's it. All right, let's make sure we got that one right. We did not. This says 5 pi over 2. So what did I do wrong? Huh. Oh, did I read it wrong? I sure did. I put 2 pi over, so shoot. I messed up, gang. So all this gets to be redone. I'm so sorry. But when you're doing live TV like this is the chance you take. Good thing I had the answers, because I knew that answer didn't look right to me. Alright, let's try this again. The period is 2 pi over k. I'm an idiot. Alright, so 2 pi over k equals, the actual period for this one is 2 pi over 5. So since 2 pi is on top, I know k has to be 5. So that's a little easier. 5 theta. Okay. And then to get c, again, same process, the phase shift. Okay, phase shift is negative c over k equals the phase shift, which is negative pi over 2. And you plug in your k. So we're going to have c over negative k is 5 equals negative pi over 2. And we're going to multiply by negative 5 on both sides. That's much better. So c will be positive 5 pi over 2. I'm so sorry about that. Everybody makes mistakes. Everybody has those days. You know how the song goes. Y'all are young. All right, last one. I'll try not to screw this one up. It is the sine. Make sure you choose the correct one. So we're going to have y equals, my amplitude is 4, so plus or minus 4 times the sine of something, and then my vertical shift is negative 1. So if you just do that, you get half the problem right. Congratulations. Okay, let's get the whole thing. So my period, again, is 2 pi over k. So that is equal to, my period for this one is pi over 4. And we cross multiply, that will be k times pi equals 2 pi times 4 divided by pi. K equals 8, as the pi will cancel, so 8 theta. And then my phase shift is equal to negative c over k, which we just figured out was negative c over k is, plugging it in, is 8, equals, my phase shift is negative 2 pi. So we're going to multiply both of these by negative 8. Those will cancel, and over here c will be positive 16 pi, because 2 negatives make a positive, so plus 16 pi. Alright, so there's your answer. Hope this has helped. Do your review over again. I may have another video doing a practice test for you. Here are the answers that we should get, and you'll see the same answers we got. Hope y'all have a great day, and we'll see you next time. And as always, stay above the line.